Hello students, here we have a question from indefinite integration. This is question number 2, and in second question this is 10th one. To evaluate, and let me tell you which exercise is this. This is 3.1, exercise 3.1 from maths paper 2, and this is a textbook. This is a textbook problem from Maharashtra State Board. Okay. So here I have a question where I have to evaluate integral sine 4x into cos 3x. So how do I evaluate? As you all know, students, integrating a function is all about applying the results. I need to be able to apply the results here. So for that, what I do is I multiply here 2. I multiply here 2. So when I multiply 2 here, this will become 2 sine 4x into cos 3x dx. Now you all would be thinking that multiplying 2, is it allowed? Yes, because now I am dividing by 2. See here, I multiply by 2, so I divide by 2. So as such, we have not changed anything. Okay, if you only multiply by 2, then it is wrong. So I multiplied and I divided. Now the question is that why am I doing so? I am trying to transform. See here, now here I have 2 sine cos. You know here 2 sine cos, defactorization formula, 2 sine A cos B is sine plus sine. 2 sine cos is sine plus sine. So this is defactorization formula. 2 sine cos is sine plus sine. So sine A plus B, and here A minus B. So 2 sine cos, sine plus sine. And what do I have here? A plus B will give me 7x, and A minus B gives me x. Now I write separate integration. So 1 upon 2 outside, integral of sine 7x dx plus integral of sine x dx. And then here I have I equals to 1 upon 2, and integration of sine 7x is minus of cos 7x upon 7 minus sine x. See students, integration of sine 7x. As you know, integration of sine of x dx is minus cos x plus c. Integration of sine of x dx is minus cos x plus c. So if I have sine of ax plus b dx, what would happen? You know it. See, sine x minus cos x plus c. So sine ax plus b minus cos ax plus b upon a plus c. You have to divide by a. You have to divide the coefficient. You have to divide by the coefficient of x, which is a. So I divide by a. Okay. Now here what's happening, students? Here you got sine of 7x. Now what does that mean? Sine of 7x means you got here ax and b is 0. B is 0. You can check 7x plus 0. So this is only ax. That b is 0. B is 0. Okay, see, sine of 7x. So you have only ax. Ax. You have only ax plus b. That b is 0. What you have? You have 7x plus 0. So it is same thing. So what will be the integration of sine 7x minus cos 7x upon 7? You divide by the coefficient of x and finally add c here. Okay, you will add c only once. No need to add it for both. So here we use that defactorization formula. This is your final answer. This is the final answer. So you understood here that integration is all about the Integration is all about applying the result. So here I couldn't apply the result. So what I did, in order to transform, first I multiplied 2, divide by 2. Then once I multiplied 2, I got 2 sine cos. So I could split it. And then I can apply the integration. Okay. Then I move to next one is I solve the next question. The next question I take from third, and it is third eighth. We need to evaluate integral of cos square x dx. Okay, so what I do is I will write let I equals to integral cos square x dx. Okay. Now see students, some of the wrong concepts which students have. Okay. So let me once again begin with what I have been always telling you. So when I have to integrate cos square x dx, see I have got list 1 and list 2, right? So I ask myself, do I have integration of cos square x in the list 1? The answer is no. If you do not know what is list 1 and list 2, you will have to see my previous videos, and in that you will know what do I mean by list 1 and list 2. Okay, this is lecture number 3. You will get this in lecture number 1. In lecture number 1, you will get this. So list 1, you don't have cos square x integration. List 2, rather I should say that I do not have a result in both the list which can be applied to integrate cos square x. That is not possible. Okay. I do not have any result in list 1, list 2, which I could apply for cos square x. That's what I want to say. But now there are some students who will think, see, now I'm telling you what are the mistakes committed by students. They think, see, they would think this way. They would think, what if I have to integrate x square? Do I have, see, I'm telling you the thoughts of a student. What if I have to integrate x square dx? So they would say that, sir, it is x raised to 2 plus 1 upon 2 plus 1 plus c, that is x raised to 3 by 3 plus c. So they would say, if x square integration is this, then why can't I apply cos x square? Because cos square x, see, cos square x is nothing but cos x square. So why can't I apply the same result here? That is, I write integration of cos x the whole square as cos x raised to 2 plus 1 3 upon 2 plus 1 3 plus c. Why I can't do this? Students, you know, this is not allowed. If you do it this way, it is wrong. It is wrong. You cannot integrate cos square x applying this result. Why? I will tell you that. See, whenever you apply a result, the first thing that you need to understand, the name of the function. What is that? What is that function? So let's name this function. What is this function? The function is variable raised to constant. The function is variable raised to constant. Correct. And what is the variable? When I call this function as variable raised to constant, what is that variable? The variable is x. The variable is x. And I'm integrating with respect to x. You understand? Yes. So remember students, this is very specific. When you apply the result of variable raised to constant, in that result, the variable you have should be same as this variable. So now here what's happening, check here what is happening. If I ask you name the function, you would say, sir, this is again same function, variable raised to constant. Don't say trigonometric function. You do see trigonometry there, but actually the main function is variable raised to constant. What is this function? Variable raised to constant. Variable raised to constant. It is variable raised to constant function. Now I ask you students, what is the variable in this? When you said variable raised to constant, it is cos x which you are referring to as variable. But here the variable with respect to which you are integrating is x. So you can just check variable, variable matching, variable, variable not matching. So not allowed. Remember, it is not allowed. So every single time you will name the function, and in that function, when you are naming it, the variable you got, if it is matching with respect to x, then only you can apply the result. Otherwise not. Otherwise not. Okay. Now, something more to it. Now, you know, students, some of the students would now be thinking, so you said we cannot. Okay, I remove this now because I hope you must have all copied it, or I can do one thing. I can write here. Okay, let me write here. Now, so some of the students would be thinking that when the variables are not matching, we are not allowed to apply the result. Then how come we apply the result? Suppose I have here, suppose I have to integrate 3x plus 2 square dx. So here what do we do? Here what do we do? Okay, no problem. Let's do this again. Name the function. What is the function here? The function is, again, check this student. The function is variable. You see that x in the base? So the function is variable raised to constant. Okay. But is that variable matching here? Is that variable matching here? My dear students, the variable isn't matching, but don't worry. Why? Because here we will use the results from list 2. Why list 2? Because see, x is replaced by ax plus b. This is allowed. This is allowed. X can be ax plus b. This is permissible. This is permitted. X can be ax plus b. This much is allowed. Nothing other than this. So I could not apply the result for cos x square. I cannot apply the result for log x square. I cannot apply for this, but I can apply for 3x plus 2 square. It will be 3x plus 2 the whole square plus 1 upon 2 plus 1. And don't forget, the coefficient of x is 3 into 3 plus c. This much is allowed. This much is allowed. On the same line, suppose if I have integration of 3x minus 7 or 3x minus 7 square dx, then I will write 3x minus 7 raised to 3 upon 2 plus 1, 3 into 3 plus c. If I have here integration of 11x plus 22 by 1, 11x plus 22 by 17 raised to 5 dx. Then, and once again, what I notice that it is variable raised to constant. I notice it is variable variable raised to constant, and the variable isn't x, that is not x, but no worries, because variable is x is replaced by ax plus b. This is allowed. So I can use the result from the list one, which will be 11x plus 22 by 17 raised to 6 upon 6 plus c, and do not forget to divide by the coefficient of x, 11. This is the answer. Okay, so students, what I wanted to tell you, I hope it is clear to you. Okay, so for integrating cos square x, what I will have to do, I will tell you shortly. I hope you have understood that you cannot use x square result here. Okay, so let's move to the next page. And so I will now integrate cos square x. And how do I do it? I'll let you know. Okay, students, there is a mistake which I committed here. Sin x dx integration is minus cos x, and I wrote it here sin x, which I will rectify. So integration of sin x plus sin plus integral sin x dx is minus cos x, as I wrote here. So it was an error which happened. So what I do, I write here cos x. Okay, now let's come to cos square x. See students, so to integrate cos square x, what I will do, once again, same word. Please understand, transformation is the key. Transformation is the key. You need to transform in order to integrate. Now, what is this? See here, how did you transform? What did you do to transform here? You applied trigonometry formulae. The same thing you will do here. What do I mean by that? See here. We all know one very important special formula. What was that? See here. 1 plus cos 2 theta. 1 plus cos 2 theta is 2 cos square theta. 1 plus cos 2 theta is 2 cos square theta. So what will be cos square theta equals to? It will be 1 plus cos 2 theta divided by 2. This is cos square theta. So I will write it here. Okay, so what I will get? I will get here I equals to, I will use this formula here. So integration of cos square x dx, I will write 1 plus cos 2x divided by 2 and dx. This is the formula. So this 1 upon 2 is out, and then I will write separate integral. Integral of 1 dx plus integral of cos 2x dx. Integral 1 by 2 is out, so integral 1 dx, integral cos 2x dx. So here I get 1 upon 2, and integration of 1 is x, plus integration of cos 2x is sine 2x upon 2 plus c, and see, it is over. So remember students, this is the way you integrate cos square x. This is the way you integrate cos square x. So what would have happened if this was not cos square x, it was sine square x? So see students, if you had here sine square x, think if it was sine square x dx, then what would I do? Very simple. For sine square x, then I will use another special formula. What is that? You know it. It is 1 minus cos 2 theta. When it is 1 plus cos 2 theta, you write 2 cos square theta. So for 1 minus cos 2 theta, you write 2 sine square theta, and then you have 1 minus cos 2 theta divided by 2. This is sine square theta. Okay. So sine square theta, I would write 1 minus cos 2 theta by 2. So the only change here will be negative and rest of the things will be okay. So this is how we do it, students. The integration of, this is how we do it, the integration of cos square x and sine square x. You need to understand that. Okay. So what you can do is you can copy this. So now I take next question, and that next question is third, 10th. I need to evaluate integral 3 upon square root of 7x minus 2 minus square root of 7x minus 5 dx. So you all understand that I have to integrate this function. I have to integrate this function of x. This is the function of x which I have to integrate. F of, you can call this as f of x or whatever. So one more thing, students, the function which you want to integrate, the function that you are integrating is known as integrand. It is known as integrand. You are integrating, so it is integrand. So what I will do, as you know, I will write this as I. This is my assumption that this integral is I. So let this. So I want to integrate this. Integration is all about application of results. So I would ask myself, do I have a result which I can apply here? Do I have a ready-made result which I can apply here? The answer is no. I cannot apply. I don't have any direct result over here. Okay. So what do I do? Once again, same thing. It is transformation. I would keep trying writing something which is equal to what I already have. See here. I will just make sure that whatever I'm writing is equal to what I'm given. Whatever I write here, my dear students, I will make sure that this is equal to what I'm given. Okay. But at the same time, I would keep trying to transform in it such a way where I could apply the result, okay. So I will just keep trying, and after some time I would find that I have transformed the given thing into a form where now the results are available from the list 1, list 2, whatever I have said earlier. Okay. So let me begin. This problem is rather very simple. You will understand it. So see here, what do? I will rationalize the denominator. I shall now rationalize the denominator. So here I have 3 upon, it is root of 7x minus 2 minus root of 7x minus 5 into root of 7x minus 2 plus root of 7x minus 5 upon root of 7x minus 2 plus root of 7x minus 5 and dx. Okay. So what I did, I multiplied the conjugate of denominator. Okay. So next step, you know, students, what it will be? It will be, you know, this is a minus b into a plus b. So a square minus b square. So you will get square of this minus square of this. So when you get the square of this, you get 7x minus 2. Then minus square of this. So here you have a negative sign and square of this. So 7x minus 5. Don't forget to put a bracket here. Okay. If you don't put a bracket for the first one, it is okay, because here you have positive sign. Here anyways you have positive sign. So even if this bracket wasn't there, no worries. But for the next one, you need to put a bracket here because here you have a negative sign. Okay. A minus b, a plus b is a square minus b square. And here what you have 3 times square root of 7x minus 2 plus square root of 7x minus 5 plus square root of 7x minus 5. Okay. Now when you open this bracket, what will happen? When you open the bracket, so when this bracket opens, you get here 3 times square root of 7x minus 2 plus square root of 7x minus 5 dx. 7x minus 5 divided by, here you get 7x minus 2 minus 7x plus 5 and dx. So you all understand, students, negative 7x and positive 7x cancel. 5 minus 2 is 3. What do you get in the denominator here? This is after opening the bracket, the sign change. 7x cancel. 5 minus 2 is 3. That 3 will get cancelled with this. So here you have, I equals to integral 3 times square root of 7x minus 2 plus square root of 7x minus 5, okay, and divide by 3 dx. What happens next, students? This 3 and 3 cancels. You have I equals to integral of square root of 7x minus 2 dx. Now see, I will write separate integral. I'm left with only this bracket plus integral square root of 7x minus 5 dx. The next step, I can write 7x minus 2 raised to half dx plus 7x minus 5 raised to half dx. And then I ask myself that after having done this much, have I reached a stage where I could apply the result? Am I available with the results now? The answer is yes. Now I have the result. Which result I have, students? The result I have is integral x raised to n dx. I have the result x raised to n dx. What is it? It is x raised to n plus 1 upon n plus 1 plus c. So now if you're thinking, sir, this is not x, it is ax plus b. Oh, it is allowed. It is allowed. It is allowed. The variable, if x is replaced by anything linear algebraic in x, it is allowed. So here it will be 7x minus 2 raised to half plus 1 divided by half plus 1 into 7. Don't forget to multiply the coefficient of x in the denominator into 7 plus, here you have 7x minus 5 raised to half plus 1 upon half plus 1 into 7 again plus c. So the answer here you get is 7x minus 2 raised to 3 by 2, and this is 3 by 2 into 7, that is 21 by 2. So 21 by 2 plus 7x minus 5 raised to 3 by 2. This is 3 by 2 into 7, that is 21 by 2 plus c. So in the next step, what will happen, students? I will take this 21 by 2. When this goes in numerator, it will become 2 upon 21, and that 2 upon 21 is common. That is the final answer. I hope you all have understood this. We will now take the next and on the next page. Thank you. Now I take question number 3rd, 5th. I solve question number 3rd, 5th. It is let I equals to integral 2x minus 7 divided by square root of 4x minus 1 dx. Okay. So what I do, see students, what do? I write this as, I multiply 1 upon 2 so that I can multiply 2 here. So if I multiply 1 upon 2, I can multiply 2 in the numerator. So this will become 4x minus 14. I repeat again, what I did, I multiplied 2 in numerator, and that's why I multiplied half outside. Now this 2 goes inside 4x, and this is 14. Okay, yes sir, very well. Now see students, so the next step what you will get is 4x minus 14 it is, and here you have square root of 4x minus 1 dx. Okay, see, you got negative of 14. Can negative of 14 be written as negative 1, negative 13? Yes, very well. See what I will do. I will write this as 1 upon 2 and it is 4x minus 1 minus 13 divided by root of 4x minus 1 dx. What I did, students, I looked at the content of the root in the denominator, which is 4x minus 1. So the numerator, I wrote minus 1 minus 13. My aim is to see the denominator repeated in numerator. Okay, denominator repeated in numerator. This is another very important step. Okay, like in the previous what you learned rationalization. See, these are the various keys of transformation. You sometimes you will have to multiply the conjugate so as to rationalize, and that is one way of transforming. Before that, what you saw defactorization formula. This is also another way of transformation. What you saw the use of special formula. This formula is another way of transformation. So these are different ways of transformation. When you will practice several problems, these all ideas will be retained with your brain. Okay, you will memorize them effortlessly. So what is important, you will have to learn them, by practicing. So here I taught you another very important transformation, that is I repeat the denominator in numerator. Okay. Now what happens, students, you all know if I have a minus b upon c, I can always write this as a over c minus b over c. Okay. So I will do the same thing, and here see what does it get me. It will get me 1 upon 2 and 4x minus 1 divided by square root of 4x minus 1 and minus 13 divided by square root of 4x minus 1 dx. Okay, then students, you all know if you have x divided by root x, then this result, this gets me the result as root of x. X divided by root x, it gets me root of x. How? Because this x is root x into root x, so one root x cancels and you are left with root x. So the same way here, what is it? It is 4x minus 1 divided by root of 4x minus 1. So it is, what would it get me, students? Then it will get me here, see, it will get me I equals to 1 upon 2, and then here it gets me square root of 4x minus 1 minus 13 times square root of 4x minus 1 and dx. Okay, then I will write 1 by 2 is out, and inside I write separate integral. So integration of 4x minus 1 dx minus here integral of 13 times square root of 4x minus 1 dx. Okay, 4x minus 1 dx. So the next step is 1 upon 2, and here I have integration of 4x minus 1 raised to half dx. Okay, and what am I planning here? I'm planning to integrate this by writing the result of x raised to n. X raised to n. I will apply which result? X raised to n, but this is not x. No worries, no worries. Why? Because it is ax plus b raised to n. That is allowed. That is allowed. Okay, x can be replaced by ax plus b. What more I have here? I write this 13 out. 1 upon root of 4x minus 1 dx. 4x minus 1 dx. And here, which result am I planning to use? Yes, very much. We have this result in the list. 1 upon root x, integration of 1 upon root x dx. We have a ready-made result in the list. 1 upon root x is 2 root x plus c. But sir, here we don't have 1 upon root x. We have 4x minus 1. No worries. Again, no worries. Why? Because this is x replaced by, see here students, x can be replaced by ax plus b. 4x plus minus 1. 4x minus 1 is ax, 4x plus b. So that is again allowed. So we have, I hope you all are understanding everything because we have done enough. I have explained you enough here. So I equals to 1 upon 2, and this gets you 4x minus 1 raised to half plus 1, that is 3 by 2, upon half plus 1, which is 3 by 2. And don't forget to multiply 4. Why 4 multiplied to the denominator? In the denominator 4, because coefficient of x is 4, minus 13 into, this is 1 upon root 4x minus 1, that is 2 root 4x minus 1, 2 root 4x minus 1, and okay, 2 root 4x minus 1, excuse me, I just messed it up. So 2 root 4x minus 1 divide by 4. Why divide by 4? Coefficient of x is 4 here. So, and the bracket is closed plus c. So you have here, this is 2 and this is 2. Okay, so what do you get? You get here 13 by 2, and this is 6 or 12. So your final answer is, you can take 1 by 2 out. So this is 1 by 4 it will become. And here you will have 3 in the denominator, 4x minus 1 raised to 3 by 2. And minus, here you have 13 times root of 4x minus 1 plus c. This is the final answer. Okay. I now take question number 4 from the same exercise 3.1. Here we are given f dash x. F dash x is x minus 3 over x cube. X minus 3 over x cube. And I'm given f of 1 as 11 over 2. And the question is to find f of x. I have to find f of x. Now here, how do I do this? Okay, before I begin with the solution, I would want you all to see this. F of x is a function of x. This is function of x. Now you all know, students, that when you differentiate f of x, when you differentiate this with respect to x, what do you get? You get f dash x. You get f dash x. Like here, if you have, so f of x, when we differentiate with respect to x, we get f dash x. So what I can say here is, what is the relation between f of x and f dash x? What is the relation? The relation is d by dx of f of x is f dash x. What is d by dx of f of x? It will be f dash x. I hope you all understand. When you differentiate f of x with respect to x, you get f dash x. So d by dx of f of x is f dash x. This is what we know. So I will use this idea. So here I write. See, this is 1 for me and this is 2. So I write from 1 we can write. From 1 we can write. What I can write? D by dx of f of x equals to x minus 3 upon x cube. Okay, what did I do, students? Nothing. I wrote exactly what I had in 1. Only this left hand side, f dash x, I wrote it as d by dx of f of x. What do I do next? What do I do next? Next, I will use the definition of integration. I will write here by definition of integration. By definition of integration. Now, what does that do? What is definition of integration? It says if derivative of a function, say f of x, is this, okay, if derivative of f of x with respect to x is this, so integration of this with respect to x will be f of x. Okay, this we have already done. So I will write by definition of integration, integral x minus 3 upon x cubed dx is equal to f of x. Derivative of this is this, so integration of this is this. Okay, and this is my equation. So now what I do, I will write separate integral here. So I have integration of x dx minus integration of 3 upon x cubed dx equals to f of x. So this is integration of x dx. This is x square upon 2. This is x square upon 2 minus 3 is a constant out. And okay, now here see what's happening, students. I would not be able to integrate this before this, you know, because I will integrate all of these at once. So since I'm not able to integrate both of these simultaneously, so I will keep this on hold. I will keep this on hold and I will write 3 out, and this is 1 upon x cube, which is x raised to minus 3 dx equals to f of x. Because when you are integrating, you should be integrating all the integrals at once. And if you want to say if you are integrating not all the integrals at once, then you will have to add different constant of integrations. Like in the previous one, what happened? I integrated. I could integrate this one, but not able to integrate this at that stage. So that was also allowed. For that, what I would have had to do was I would have had to add the constant of integration for this, like plus C1. You understand? Later when I integrate this, write plus C2. But I wanted to avoid it. That's why I didn't do it. I will integrate all this at once. So integration of x is x square by 2 minus 3. And this is x raised to minus 3 plus 1 upon minus 3 plus 1. Okay. Plus c equal to f of x. So this gets me x square by 2. This is minus 2. So it will become plus 3 by 2. And into x raised to minus 2, which is 1 upon x square plus c equal to f of x. So this is my equation number 4. Sorry, 3. So students, I got f of x. They had demanded f of x, and I have obtained f of x. But in my f of x, the c is still left. I need to find the value of c, and for that they have given me one condition, one data. What is that? They give f of 1 as 11 by 2. So I will write here, put x equals to 11 in 3. I write here, put x equals to 11. Put x equals to 11 in 3. Therefore, we get, I'm sorry students, it is not 11, it is actually 1. So put x equals to 1. You know, this happens sometimes. Put x equals to 1 in 3. So it will get me f of 1. So we get, what do you get? Therefore, we get here, this is 1 square by 2. You're writing x as 1. So this will, when you write x as 1 here, 1 square by 2 is 1 by 2 plus 3 by 2, because this will be 3 by 2, because once again what's happening is 3 by 2, 1 upon 1 square is 1, plus c equals to f of 1. What is f of, and here you have f of 1. You're putting x as 1. So next step, what you get? So you get 1 by 2 plus 3 by 2 is 4 by 2. 4 by 2 plus c equals to f of 1. F of 1 is given as 11 by 2. See students, here I have f of 1 because I had put x as 1. So c equals to 11 by 2 minus 4 by 2. So c equals to 7 by 2. Once I got c, what I will do? I will write using c in 3. Using c in 3, we get, what do we get? You can check. So we will get f of x is equal to, therefore the final thing I will get, f of x is equal to x square by 2 plus 3 by 2 x square plus 7 by 2. X square by 2 plus 3 by 2 x square plus 7 by 2. This is f of x. I hope you all have understood. Thank you.